In this lesson, we're going to take a look at accuracy, precision, and percent error. Now, precision, we've actually kind of looked at before. When we were looking at significant digits, that's when we're talking about how precise something is. So when we say precision, or how precise something is, all we mean is repeatability, or you can think of this as significant digits. So it's repeatable because the more precise a measure is, the more people will measure it the same way. Remember that last place in a measurement is always estimated, and the further that last place is to the right, the more numbers we'll have in agreement, so the more repeatability we'll get with a precise measuring device. Now, accuracy is something entirely kind of different. Accuracy is how correct a measure is. Okay? Now, what that means is how close to the correct measurement you get with your measuring device. If your accuracy is wrong, then even if you have a very precise measure, but your measuring device was inaccurate, you will have a precise measure that's wrong. So if you think something is 23.876 centimeters long, but your ruler's wrong and it's really 27.938 centimeters long, it doesn't matter how precise you are, you're still wrong. Okay, so accuracy is how correct a measurement is, or how close to being correct the measurement that you make is. Now, how do we actually know what the correct value of a measurement is? Well, it depends on what substance we're dealing with and what measurement we're making. But for a lot of things, it's because there's been hundreds of thousands of measurements of these things made over the years, and so we have a nice average using very precise instruments of what we expect the actual measurement of something to be. Now, we actually have a way to describe accuracy, and we do that with percent error. Percent error tells us how big is our error compared to our measurement. So what we do is we take the absolute value of our measurement minus the accepted measurement, and we divide that by our accepted value. Measured minus accepted over accepted. Now, absolute value, so we always get a positive percent error. Sometimes your measured value will be bigger than the accepted value, sometimes it'll be smaller than the accepted value. The absolute value gets rid of the negatives that we have to deal with. You'll notice this is just telling me how far apart two measurements are. So if we measured something to be 9.8 centimeters, but the accepted value of it is 9.6 centimeters, then we would take our 9.8 minus 9.6, and that gets us our difference of 0.2 centimeters, and we would then divide that by our accepted value of 9.6, divide by 9.6, and then multiply it by 100, so I should put that over here, times 100% to make it a percent. Now, a small percent error means that our measurement's very accurate. A larger percent error means that our measurement is inaccurate. And you'll notice 0.2 centimeters of 9.6 centimeters is going to be a fairly low percent error. But if I had a 0.2 centimeter error on a 1 centimeter measurement, that's quite a bit more. Okay, that is a 20% error. That's a lot bigger error, even though it's the same size inaccuracy. And that's what's nice about this percent error. It tells us how worried about that inaccuracy do we need to be. We don't need to be worried about a 0.2 centimeter inaccuracy when we're talking about a long distance, but we do need to be worried about a 0.2 centimeter inaccuracy when the distance is much shorter.